And then welcome everyone to today's meetup on writing Semgrep rules for security, performance, correctness, and many more things. And today, Isaac from r2c will be presenting. We did structure this meetup to be fairly interactive. So please, at any time, chime in with your questions, thoughts, suggestions, ideas. In the future, as we host more of these meetups, sometimes we'll have people presenting from the outside who maybe are working with Semgrep, maybe some who aren't. For example, in the past, we had Ajahn Abraham present and Julia Lawal in the past meetups. You can find those recordings on YouTube. But we'd also like to make some of these more interactive and have more of a group discussion and for people to share ideas. We've seen that happening on our community Slack, and it's some great interaction that's happening. So we thought we might do that a bit live as well. And as I mentioned earlier, we will be publishing this recording to the r2c YouTube channel. So with that, Isaac, I'll let you take it away, and I'll interrupt you if I see any questions in the chat.
Okay, sounds good. Thanks, Pablo. All right, I am going to switch over to the presentation mode. And is that coming through okay?
That looks good, yeah.
Awesome. Cool. Yeah, well, welcome everybody. This is a pretty friendly session. We're going to be talking about specifically writing Semgrep rules for security, correctness, performance, and more. This is really geared at people who have at least some degree of experience with Semgrep. So if you feel a little swept along, don't worry about it too much. I will start out with a kind of short overview of what Semgrep is and why it might be useful for you use cases and applications. But before I get into that, so here's a little bit about me. I'm one of the co-founders at r2c. Previously, I did undergrad and image at MIT, and then spent some time at MIT Lincoln Labs in the DoD. r2c is a startup in San Francisco building a business around open source primarily and next generation static analysis tools that we're working on developing. And our outline for today, as promised, we will start with a short intro about what is Semgrep, why might it be useful to me, and then we'll dig into a couple different categories. So first, security, second, correctness, after that, performance. And for each of these, actually, we'll talk a little bit about not just, oh, here is an exercise that we'll go through about we have a target, we'd like to find something like this, we'll write a Semgrep rule for it. I'll also talk a little bit about how we and some of the people in the community are coming up with the ideas for rules under each of these categories. And then at the end, if you are like, oh man, I think I know there is everything to know about Semgrep, we'll talk about advanced features with the engine that are maybe hidden things that we haven't talked about publicly yet, as well as a little bit of a roadmap in terms of, hey, like where is Semgrep heading over the next couple of weeks? Yeah, does that sound good, Pablo? Just checking in.
Yep, that sounds great. Your audio is loud and clear.
Okay, fantastic. So to get started, here's the TLDR on Semgrep. It is a lightweight, customizable static analysis tool. We've tried to make it as much as possible batteries included. So we now have hundreds of rules written by people in the community. Each rule can have multiple patterns. So we have, I think, like over 10,000 patterns that people have written from the community, which is pretty cool. And the idea with Semgrep is to be able to combine the sort of speed and cheap iteration customizability of grep with the expressiveness of traditional static analysis tooling. Notably, compared to many other tools, Semgrep runs totally offline. It runs on uncompiled code. It's not quite as fast as grep, but it is much faster than probably other static analysis that you might be used to. And it is open source, so Semgrep is LGPL. In fact, if you don't know this, there's some cool history about the Semgrep project. It was actually originally a Facebook project. It started at Facebook in 2009. And the principal author at Facebook actually joined r2c back in 2019. So it has a sort of long history and lineage, which hopefully means that there are fewer bugs for you to run into. And the final piece is that when you're talking about writing custom rules, there's not a really painful domain-specific language that you need to learn. Generally speaking, the patterns are going to look like the source code that you're targeting. And at the bottom here, we have the languages that are currently supported in either alpha, beta, or fully supported status inside Semgrep. So generally speaking, I think there's a sort of spectrum of complexity. it's actually been really surprising to me, as we've published this tool, to learn how effective grep can be for a lot of teams. Like if you are looking for an API that has a very particular name, so thinking, for instance, in a web framework like React, you have an API like dangerously set inner HTML. You can grep for that, and you can end up being pretty precise in terms of finding all of the escape hatches to the use of a secure by default framework inside your application. On the other hand, there are certain things that only a very, very sophisticated, very, very expensive analysis can actually find for you. And so the idea with Semgrep is to try to occupy a place in between these two and get the best of both worlds. So we know that static analysis tooling is best when it's highly tuned to the application. When a development team or a security team spends the time to put the effort in to say, hey, like, what is actually going to be bugs that bite us inside our application? That's great. So if you can have that customizability, but still have the sort of speed and easy to use and easy to learn nature of something like grep, that's the position that Semgrep is trying to occupy. So what's new since our last meetup, which was in June? We had the 0.9 release. We actually release every Tuesday, so we're up to 0.21. The big news headliners is that there's a Ruby beta, JSX, which is JavaScript extension, allows you to mix JavaScript and HTML if you're not familiar with it. JSON and OCaml beta were all added. In fact, under the hood, we did a very ambitious, essentially a rewrite of the parser core of the whole library. So there is a library published by GitHub, which is used in some of their editors named TreeSitter, which specializes in sort of high performance reading from a buffer into a parse tree. And we switched from the Facebook era parsers in most of our language support to using that under the hood, which has fixed a wide swath of bugs. So for instance, our previous Java support for generics was a very ad hoc mechanism, and now we're using a proper parser for it. So that's been great. Metavariable regex adds the capability to perform a regular expression on a captured metavariable. If you don't know what that means, don't worry, we'll talk about it later. We also added a bunch of features that just make Semgrep more performant on sort of real world code bases. So a lot of the times people will end up checking in vendored code in massive minified files. There's a timeout where basically we won't waste time parsing those files if it takes longer than a few seconds, as well as a max memory option. There is a really cool new feature that we're very excited to show you, which is still in beta, for pattern from code, where you can just highlight some code and then instantly see the Semgrep pattern that would match it, or a couple variations on that pattern. There's alpha support for taint tracking work. And then in terms of the integrations, the pre-commit hook now works without Docker, so it's native, which is awesome. There's an editor extension for Visual Studio Code. We improved the constant propagation quite a bit. And if you haven't checked it out, there's a whole new semgrep.dev and semgrep.live, which we're pretty excited about. And this is a subset of the changes that we made. So see the changelog file. These slides will be linked later, and you can click on the hyperlinks inside them. But that is a whirlwind view of what's new since the last meetup. And just before I dive into actually doing some of the exercises, we're going to have a recap here. But if you want to follow along, which I would highly, highly recommend, there's a couple ways you can do that. So you can go open semgrep.live in your browser right now. That's probably the most convenient way. And actually, I would recommend doing that. I'm going to be demoing off of the live editor for all of the examples. If you want to take some of the things that we're writing and run them on your own code, locally and offline while we're doing these exercises, you can also either brew or pip install Semgrep. If for whatever reason you don't have access to brew or pip, it's also available to run inside a Docker container. So yeah, semgrep.live is probably the easiest way to get started. So 3 key things on the Semgrep recap, just for those who may not be familiar with all the features. The first one, there's really nothing to learn here. This is just something that you get for free, is code equivalences. So the idea with Semgrep, when it was at Facebook, it was a syntactic grep, and we've tried to convert it into more and more of a semantic grep. The concept here is that because we know about the semantics of the language, one pattern should be able to match all variations of equivalent code. So for instance, in the second example here, you see we're calling foo with keyword 1 equals 1, keyword 2 equals 2. And even though at an AST level, the thing on the right with foo keyword 2 equals 2 and keyword 1 equals 1, keyword 3 equals 3 is pretty different. So if we were just doing a true tree matcher, that's not something that would match. Because Semgrep is not language independent and it actually has special parsing modes and equivalences for each of the supported languages, Semgrep understands that, hey, this is Python. In Python, these are keyword arguments, and the order of keyword arguments doesn't matter. So the pattern that we wrote on the left-hand side is still going to match the pattern on the right-hand side. This is really valuable, like even if you're just doing things that are sort of basic at an AST level, because you kind of get expertise about the language for free, right? If there are 4 ways to call a function in Ruby, you don't need to know about the 4 ways to call a function. You just need to write one of the variations, and Semgrep should generalize that to all of the equivalent code patterns inside the code base. So you can see on this slide a couple other examples, and we'll talk about some of them further on in the presentation. But so you get this for free. The second example is the ... operator or ellipsis operator, which basically lets us say, hey, like we want to abstract away some list of arguments, parameters, characters, or statements. So we don't care about what's going on, like before the last argument here. We just want the last argument to be 5. So this is going to match these two. Similarly, we can use that inside a string, which is just a sequence of characters, to say, hey, we don't care about what the sequence of characters is. And we can also use it inside a list of statements. So this will abstract away as many statements at the same level between this get call and this eval call. So we'll see more examples of that. And like I think this is pretty well documented at this point in most of our materials. So hopefully you're familiar with it. The last bit, and we'll spend a good amount of time talking about this today, is metavariables. So these, rather than just saying, hey, like I don't care, function more like a capture group in a traditional regular expression. And they allow us to just grab something from the code and match it. So here, for instance, we're grabbing the first argument of this call to foo. So x is going to be bound to 1. We can use that to grab not just a single identifier, but an expression. So here, e is going to be bound to the expression x greater than 2. And then the really interesting thing, so there's some rules about this. You have to start with a $sign and then have uppercase ASCII characters. You can match expressions, statements, names. The really cool thing is when you start to use this with an equality constraint. So if you reuse that same metavariable, Semgrep is going to enforce an equality constraint on it for you. So in this example, we've got x equals x. This is like the most basic trivial example of metavariables. That's going to match if a plus b equals a plus b, but it won't match something like a plus b equals a plus c. And you can use that both on the like sort of individual expression level, as well as in blocks like this, where we've got $s and $s are going to glob and grab all of the statements here, and they're going to trigger on this code, but not something that had a different set of statements inside the if block or the else block of that expression. Yeah, so Pablo, any questions so far? I imagine this is probably review for a lot of people, so I'm just going to keep moving. If not,
no questions.
All right, fantastic. So now let's start to get into the actual rule writing part of the session. So here I think we come to the question of, okay, so you've got this really cool pattern matching capability. What exactly is it good for? And no surprise if you've looked at like r2c.dev, the company behind this, our primary use case is security. And under this, we have a couple specific categories. So we've seen people get a good amount of leverage from using Semgrep for sort of basic compliance work. Also, people have used it to hunt 0 days. And then I think my personal favorite is basically using Semgrep to eradicate bug classes. So if you are able to come through a code base and say, hey, like by looking at this, doing actual code inspection, I can guarantee that we don't have any bugs of this type. It's a really, really powerful capability that can obviate the need for all sorts of other security tooling down the line. If you can just prove to me, hey, like it's impossible for this application to have SQL injection by a relatively simple inspection. The other thing that we, in fact, ourselves use it for quite a bit is correctness. So essentially, like the highest leverage thing here is if you have something and you're like, oh man, this would make a good linter plugin, you can just rapidly prototype that in Semgrep. And oftentimes, and our goal is that increasingly, those rapidly prototyped lint style checks are actually good enough to replace the need to actually go and build a full-fledged plugin. And hopefully, eventually, the Semgrep capabilities will go beyond the capabilities that are offered in a typical linter. And then the last category is performance. So here, there are a couple, sort of different levels. There's language level performance anti-patterns, like triply nested for loops, for instance, or things that are just like known to be slow. And then there are also very, very specific performance anti-patterns. So I'm going to have some fun with this one. We're actually going to show you an example of a Semgrep rule that runs on the Semgrep code base based off of a bug that we received about performance in Semgrep. So yeah, without further ado, I guess I'm going to drop into the security rules. And for each of these, as I promised at the start, we're going to sort of have an introduction that's going to talk about, okay, like where are we getting the ideas for these rules? And then we'll actually go and write a very, very specific example. And we'll do it by basically, I'll give you a URL and as a live editor. That's kind of the exercise. I'll let you try to figure it out yourself or follow along as I basically live code it. So please be kind. There's going to be a lot of live demoing here, and I'm not a perfect Semgrep rule writer by any means. So starting out under the security rule case, the most basic thing is compliance, which is probably not super fun to talk about, but oftentimes wields a very big stick in terms of becoming a priority for an organization. And one of the coolest things that's been going on behind the scenes is that some of the folks in the Semgrep Slack are actually very involved with OWASP, and in particular the ASVS projects and the cheat sheet projects. Clint Gibbler, who joined us, who used to be the director of research at NCC Group, has a lot of connections to OWASP as well. And so the idea here is to basically get out of the box support for, hey, there's this ASVS level 1, which is actually designed to be automated. And so we should be able to basically convert this cheat sheet from a kind of English readable human knowledge to an executable spec. This is exactly how it was designed to verify, oh, like, are we compliant with this OWASP standard? Similarly, when you're reading a cheat sheet, it's really cool to be able to say, hey, like, you can actually just like run semgrep -- config, my cheat sheet URL, and you'll actually immediately find local code that violates the best practices listed in this cheat sheet. So if you want to get involved, there's going to be a link on the slide. But a big shout out to Daniel, Joe, and Rohit, who have been involved in this project. It's been really cool, and it's been a very powerful source of Semgrep rules. Now, obviously, there is sort of like the traditional compliance standards like HIPAA and things like that. Those are a little more vague, to be honest, in a lot of ways when it comes to actual AppSec and ProdSec. So what we like about the OWASP collaboration is that it tends to be much more specific and translates very clearly into Semgrep rules. So let's look at one of these specifically. If we were writing a Golang application and we were like building a web server, basically, one of the controls might say, hey, like our web server should always try to serve over HTTPS, using TLS. It should not instantiate a plain HTTP connection. And in this exercise, we're actually going to try to go above and beyond. So we're going to try to provide an auto fix for this functionality, so that if we're bothering the developer with our compliance complaint, the developer might be like, I get it. I don't really want to have to think about this. I really wish you could just take care of this for me. So I'm going to open up the live editor. Probably you've seen this before.
Isaac?
Yeah.
I will paste the link to that in the chat. So
oh, fantastic.
Click on it there.
Yeah, thanks, Pablo. That's great. Cool. So I'll give everybody a second to load that up. Super. So if you haven't been to the live editor in a while, there's a couple changes. So first off, everything here, if you have a local Semgrep install, you can just run this locally by saying semgrep -- config, and then the share URL for it right here. And it also has instructions for setting it up in CI. Basically, the other change we made is there's a simple editor and an advanced editor. So the advanced editor is actually what you've seen before. It's the YAML format that Semgrep accepts. The simple editor is not actually that different. It's just editing the YAML behind the scenes, but it avoids you having to memorize the names of the YAML keys and worry about YAML formatting, which is one of the worst wonders of the modern programming world, in my opinion. So let's look at the code snippet that we've got here. We're going to scroll down a little bit. We see that the developer is instantiating, in this case, an HTTP client. So I misremembered the example. What we're actually looking for here is the fact that they instantiated a client that will accept TLS version SSL 3.0. So in case you're not familiar with the nuance of this, SSL 3.0 is now 100% deprecated. Nobody's supposed to be using it anywhere anymore. It was superseded by TLS, which is a little bit confusing because by name, they sound like the same thing. In fact, they're not. And so what we'd like to find is basically anybody instantiating a TLS config object that has min version TLS version SSL 3.0. And then really what we'd like to replace that with is TLS.version TLS 1.3. So this is actually, like, if we were to leave a comment, we would say, please use TLS 1.3. So, fairly straightforward compliance thing is like, oh yes, you have to be using the minimum version of crypto, which is required for some compliance standard. Back when I worked with some government people, this was the sort of thing that just drove them nuts. So, a lot of time in Semgrep, we can get away with just kind of copying and pasting code into the code box. So I'm just going to start by copying tls.config, and then I'll grab min version SSL 3.0. I'll put it like this. And I really like to just rapidly iterate as I develop the rules. To me, that's the whole point of using a live editor, is that you can get it wrong the first time and it's not really going to matter. So if I press run, this is not going to trigger on anything. So we've got no matches over on the right. And the reason why is that this structure, which is being created, has a bunch more parameters inside it. So we're not implicitly matching just because we've specified one of the parameters that we care about. So again, we talked about this in the sort of quick recap of Semgrep. We'll basically just put the ... operator before and after this. So I'll give you a second to parse that. And once we've done that, we're basically saying, yeah, we don't care about what comes before this or what comes after this. Of course, this being Golang, the order of objects in the struct doesn't matter, if I recall correctly. And so now we are successfully triggering on this inside the code base. So that's great. We should be able to verify that if we change something like here, if we change it to SSL 4.0, it's not going to trigger. So that's fantastic. So now the question is, okay, so we wrote a basic compliance check. We have succeeded in being annoying to whatever developer is maintaining this code base. If we have some sort of responsibility as a senior developer or as a security person to make sure that these issues are fixed, this is probably good enough to deploy to CI. But I would like to go a little bit of a step further and say, hey, how do we just automatically fix this? Since Semgrep now has a Visual Studio Code extension and a few other editor extensions in the works from other contributors, if we're able to provide an autofix suggestion, that's going to be really cool because now it can actually just appear as an IntelliSense style prompt inside the user's editor. Great. So for this, we are going to switch. So you can see I've got an autofix field here. I'm actually going to show you something that is a little bit more nuanced and one of the new features that got added to Semgrep. So instead of just using a straightforward fix, I'm going to use a fix regex. And what fix regex lets me do is basically say, okay, I would like to find this regex inside the source code, and then I would like to replace it with some other regex. So essentially, this is still pretty dumb, right? We're basically cobbling on a kind of sed-like tool to the specific AST area extraction that we did with Semgrep. So in particular, we talked about this before, I would really like to replace version SSL 3.0 with version TLS 1.3. So I'm just going to drop in this as the regex, and I'm going to drop in version TLS 1.3 as the replacement. And let's see what happens. Boom. So this looks pretty good. The formatting is a little wonky here, but you can see that in the fix, we've got min version TLS version 1.3. And actually, maybe I'll just take out these comments because they're kind of interfering with the preview of the fix. So I'm gonna run that. That looks pretty good. If I click apply, yep, looks like we've successfully forward patched it to have TLS version 1.3 inside the code base. So cool. That's the gist of it. Any questions based off of that example? Pablo, can you confirm? I can't see the
No questions.
Okay, cool.
And Eric confirms yes.
Excellent. All right, so that was compliance. Compliance is kind of boring, but expect a lot more energy here just because this tends to be such an important thing for people who are working on large teams or companies. The next example is a lot more fun, I think, and this basically comes down to either auditing a code base or hunting. So we had somebody at one of the FANG companies as part of their internship actually find a 0-day in their company's code base following this exact kind of workflow. Basically just freeform, blue ocean, using Semgrep to say, I wonder if anybody is doing something that looks like this inside the code base. And so really your creativity is the only limit for getting ideas here. But generally speaking, compliance requirements can be a nice starting point for these sorts of things because they tend to be grounded in some sort of reality. If you're using a framework underneath, blog posts about new features in that framework or like new features that were recently added to your code base can be a good place to mine, to just look for kind of deviously minding, I wonder if they remembered to do this. And then surprisingly, the documentation for both frameworks and languages, I have found to be a very fertile source of sort of caveats. So in particular, if you're reading the documentation and you see a call out box that's like, hey, like warning, never do this in production, that's an awesome thing to just quickly write a cheap pattern and search for. And actually the example that I'm about to show you comes from a friend of the firm who is a hacker. Professionally, Vasily is one of the top 3 bug bounty participants on HackerOne for the entire Node.js project. So he's very accomplished. And he wrote a fantastic blog post looking at JWT mistakes. So if you're not familiar with JWT, JWT is JSON Web Token. It's an open standard like defined by r2c, which is basically a replacement for cookie-based authentication is, I guess, the simplified form. And so what we're going to do, like you can see a snippet which is taken from his blog post right here. We're going to try to define, and discover an example where somebody has just like outright hard-coded their JWT credentials into the code that they published. So we can take this and scale it up a little bit. We could run it on like a couple thousand or 10,000 repos on GitHub if we wanted. But Pablo, if you wouldn't mind going through and putting the exercise example in the chat.
Yep, you got it.
I'm gonna click through to it as well. All right. So here you can see that we've got JSON WT. This is JavaScript now. So I do apologize. I'm going to be switching languages quite a bit. We don't really have a majority language, unfortunately, that most people are writing Semgrep rules in. So we're going to do Python, JavaScript, Go, maybe a little Java, the works. And what we can see here is that basically people are calling JSON WT.sign with some kind of payload and then the secret. And here the secret is hard-coded string. Here it's actually passed as the second parameter to this call. So again, we're probably going to start by basically saying, hey, I want to, maybe we'll start with the second example because that looks a little bit easier. So I'm going to copy this into here. I'm going to say, hey, okay, JSON WT dot sign payload some secret. Again, I don't think this is actually going to be necessarily correct. So I'm just going to run it. And yes, that looks correct. But if I change this to be some secret 2, it's not going to work anymore. So that's not so great. What we can do, though, is we can say basically oh, okay, the secret, if it shows up as a string literal using that ... operator, now we should be able to match anything that shows up as a hard-coded string. So that's pretty good. But now we have a problem where, okay, what if somebody imported it as, const JSON WT2? So I suspect that we're only going to trigger on the first example. That's definitely not what we wanted. So instead, we're going to go back and use the ellipsis operator again. We're basically going to say hey, const metavariable JWT equals require JSON web token, like this. And then we don't really care what comes between this and the usage. So we're just going to put a ... And then we'll say $JWT.sign some payload. Well, I don't actually care about the name of the payload. So I'm just going to replace that with a metavariable. Oops, like this. And now hopefully what we'll see is that we capture the second case on line 17 with this expression. Nope, we are not. So I did something wrong. I think I forgot potentially a semicolon inside this expression. Yep, so I did. And this is something that's a little bit subtle about Semgrep, by the way. So sometimes in order to be parsed as a statement rather than as an expression, you need to explicitly add the semicolon into the pattern so that the AST matcher interprets it as a statement rather than an expression. Okay, so this is pretty good. And actually, even though we started with the second example, you'll see that we are actually still matching on the first example. So this is because there's a little bit of constant propagation going on here behind the scenes for us. Semgrep understands that this shush being assigned a secret and then immediately used because it's a const is actually equivalent to it being used as an immediate. So that's pretty cool. Like this feature has been evolving and growing. It won't handle all cases, but it should handle if we say, like const like my JW key, even though we're not in the function, equals ABC, and we put it here. It should still trigger on that, which it does. But if we make it, something like input like this, a function call, it doesn't trigger. So that's pretty cool. That's an example of, again, behind the scenes, we wrote a relatively simple pattern, and Semgrep tried to figure out, like, hey, where are all the equivalent variations where this pattern ought to apply? Cool. So any questions about that example?
Nothing in the chat right now, but
All right.
feel free to type it in if you have something.
For sure. So far we covered under the security use cases, compliance. We talked about kind of auditing and hunting. The last one I'd like to talk about in a little more detail, and actually I'm particularly passionate about this because I am giving a virtual presentation with Clint Gibler, who will be my co-presenter at Global AppSec SF. And he actually wrote the content of the slides, so I want to give a shout out to him. When we think about like using a tool like Semgrep, it's not really appropriate for a kind of traditional static analysis security tooling workflow. Traditional static analysis tool does a lot of work to identify, hey, like this is a false positive because this input does not actually come from the user. It couldn't possibly be user controlled. And to do that, it requires a lot more work to interpret the program and provide a very detailed whole program analysis to understand, like, hey, like, could this possibly be coming from the user input? What we've noticed is that a lot of security teams, even teams at very, very large companies, say Google, have turned to the use of frameworks that just tend to avoid those security issues altogether. And using those frameworks along with some very lightweight static analysis tooling allows you to basically say, hey, like, I can actually prove to you that this application does not have any defects of the type XSS or any defects of the type SQL injection. So when we think about like Semgrep as a use for this, the obvious question is, well, hey, where would you even start about trying to eradicate a bug class? XSS is a pretty big bug class. And really, like this is something that it can be done in a generic way, but I think it makes the most sense when it's highly specific to your team. So here are some of the things that we recommend and that we've seen others do. You're looking at issues on the issue tracker that are tagged security, capturing a list of security relevant keywords and then scanning those in the PR flow, the git commit history, the issue trackers, git log -- grep, looking at prior security tool reporting, pen test reports, the bug bounty, asking the development ops team, for example. So if you follow all of these, you're going to have a very long list of bugs. And then the next step is to basically slice and dice. So to group by vulnerability class, group by the source of the vulnerability, try to do some weighting based off of the severity or the impact. And then I think it's really helpful to basically look at the bug class and review how did the development team fix this issue? What did the vulnerable code look like? What did the fix look like? And a bug class is a good candidate if the vulnerable code starts to look pretty similar. It's a bad candidate if it all looks different, right? So you can kind of intuit some of these things. There's actually a really great presentation, which is linked here in the slides, on data-driven bug bounty programs. So if you're not familiar with the concept of a bug bounty, it's basically, hey, let's pay people to report vulnerabilities to us rather than letting them sell them to a third party or somebody else. And they've proven highly effective at actually exposing true issues inside application or product security. So once you slice and dice this, you should have a pretty good idea of, like, there will probably be a power distribution where it's a couple categories that you're just seeing over and over again. And some of those might be good candidates to use Semgrep for. So the example that we're going to do here is SQL injection in Python Django. So we actually have been working with Jacob Kaplan-Moss, who's one of the co-authors and the original author of the Python Django framework, one of the most popular frameworks for Python, on writing a set of rules that are comprehensive enough to cover all of the various ways that if you're using a standard framework designed to work with Django, what are the various ways by which you can shoot yourself in the foot and experience SQL injection. So I'm going to click through this link again. Pablo, if you wouldn't mind sending it out to the group.
Yep, and there's actually a question maybe before you start on this one about the
Yeah.
previous example. And the JWT example, if the constant was defined in a separate file or a config file, would it be matched?
Yes, that's a great question. So right now, none of the sort of work that Semgrep does with equivalences apply on an inter-file basis. They're only intra-file. And some of the work is not even inter-procedural, it's just intra-procedural. So intra means like within. So to answer your question, no, it will not consider other files. Now, will this change in the future? This is actually one of the things right now that makes Semgrep very fast. It's possible to shard the analysis on a per file basis. And so this is something that we're like thinking about, but is not on the immediate roadmap to change, just because, you know, like the sort of philosophical position that we would take is, you know, hey, if it requires you going and looking at another file that might not even be involved in the pull request that's changing this functionality, it's actually not a very good developer experience to say, oh, you have to like go hunt down potentially multiple files in order to prove to yourself that this is secure or that it's not secure. It would be much better if we could look at the immediate context and conclude, oh, this is fetching from an environment variable. I know that that's the preferred way to do things at our organization rather than being a constant string. But that is a very good question, and it's certainly a weakness of the tool that, you know, it won't range across files for the analysis that it performs.
Cool, thank you, Isaac.
Yeah, absolutely. All right, so I'll give you a second to look at the code for this example. Again, I know I'm switching through languages quite a bit, but basically we've got a couple different methods for invoking the raw SQL APIs inside Django. So Django specifically is using an ORM. In this case, our ORM sort of looks like SQL Alchemy. So we've got this person object, and to access raw SQL queries on that table, or just in general, we can call the .raw operator on the objects method inside a identifier that is of type person. So here we've got a query which is being constructed. This is a fragment of code, right? This is an executable. L name isn't even defined. Our goal with this query is we just want to know anytime somebody is, you know, sort of breaking out of the escape hatch that's built into the ORM to allow for raw SQL querying. So we would want to trigger on line 4. You know, if somebody for some reason is not actually passing any arguments to it, that would be fine. If they're passing a hard-coded string to it, that should also be fine. You know, and here is another escape hatch that people are using, this like import raw SQL thing to create a query that could have user input. So at the most basic level, well, I'll let you think about this a little bit. It's going to require more than one query in order to accomplish it and capture both cases. Yeah. Cool. So I'm gonna steam ahead. The first thing is we actually can't solve this perfectly with Semgrep because this is Python. Python is an untyped language. So this thing here, person, we don't actually know what type person has. We just know that if it's a SQL Alchemy model, calling .objects.raw on it is going to allow us to have the query. So we might have some false positives, but what I'm going to propose we do is basically say, hey, model, which is just a meta variable that's going to capture any model, .objects.raw, and then we'll put the query here like this, and we'll say, yeah, like you can have more arguments to it, but we don't care about that. So let's see what happens. We used this meta variable here to extract the query, which was good. And then you can see that because we have specified at least one parameter and we don't care about more, we're not firing on line 8, which is pretty nice. So what about the second example? So here we're going to do something we haven't done before. We're going to press the plus button. And you can see that by default that says or is. There are a couple different operators that we can use. So we can say is not inside, and is inside. These can be really useful for increasing the precision of your query. In this case, we're just going to use the or is to group it with a related idea that is not quite the same. So I'm going to start by doing something fairly basic. I'm just going to say, hey, anytime you use .raw, like raw SQL, dot, 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 we're going to trigger on it. And I'm doing this even though I know it's actually not going to work to illustrate one of the sharp edges in Semgrep that we haven't quite fixed yet. So here you can see that like somebody created an object called r2c, which just like literally does nothing. And then they called it with a constant string. And we're triggering on this case, which is bad because that's definitely not a vulnerability, although maybe it's questionable that they created a function named r2c. What we really want is we want to be triggering right down here on the actual r2c imported from the Django DB expressions thing, which is the escape hatch that we care about. And so with Semgrep, oh, Paulo.
Yep, there's a question. What is inside in the context of a rule?
Yeah, we'll have an example that touches on that later. So if we can hold the question, I think we're running a little bit low on time because we've got about 15 minutes left. I will promise to get to it later. So steaming along, what we're missing here in the sharp edge is that we need to fully qualify r2c. So because we imported it from Django DB models expressions, we basically need to say, hey, Django DB models expressions dot r2c. And then if we run that, we should now not trigger on line 12, but successfully trigger on line 16. So this is pretty good. Like we've basically successfully, you could see that we could add some more things here. If we switch over to the advanced editor, you'll see that what it did was it put this pattern either key with 2 subpatterns underneath it. If you go to the docs and you look at rule logic, this actually covers all the details on the various operator types that are available in excruciating detail and how the matching works. So if I run out of time, you can go there to get the details on what the pattern inside operator actually does. So we drilled down pretty deep into eradicating bug classes with an example. There's a completed example that you can pull up, but I'll let you do that when you're reading through the slides. And we'll move on to rules that touch on correctness. So how do you get ideas for correctness bugs? One of my favorite sources actually, and empirically, the best rules that we've written, because we score them extensively, come from just lists of bizarre behavior inside programming languages. So there's a WTF Python list, there's a WTF JS list, and there are similar lists that have been compiled over the years, which are just sort of, this is a real gotcha. Bet you didn't know this about the language, and it can result in really nice, subtle bugs. You can also build on rules that you find in existing linters. Those are often, like empirically, those are going to be great sources, and expanding them a little bit can be valuable. The language documentation getting started guide for the languages will often have a lot of details about nuances. And then, of course, there's a lot of academic research that happens on like, hey, like what are the correctness bugs that happen inside various programming languages? Those are all pretty generic. Actually, my favorite example for correctness on how to get ideas comes from doing things that are hyper-specific to a code base. So we have an internal tool, which is not open source, that we use on consulting engagements, where it will run Semgrep back in time over a repository. And this is an example that I found mining an Apache project named Airflow, where they were basically like, hey, like, we thought that subprocess.call would actually throw an exception if this command failed. It turns out that wasn't true. It just puts the return code in a variable and does not throw an exception. What we meant to do was check call. And so I was able to write a Semgrep rule, which was basically like, hey, if you're using subprocess.call and you're not assigning it to anything or checking the return value in any way, you probably meant to do subprocess.checkCall. Maybe not, but probably. And that ended up being highly effective and high signal. And here you can see the exact commit with Semgrep making a transition from 4 instances of it to 3 instances of it on the fixed commit. So here's an example that comes from WTF Python. So you can see number 2 here, we've got string A, string B. If we ask A is B, it's true. If we do the same thing, A is B is false. That's because these are object references that are being compared rather than value references. So again, Pablo, if you can drop this in the chat. There's actually a bunch of examples in here, but we're just going to do a fairly basic one. So we're going to say essentially like, okay, our string is comparison rule should fire on cases like this. So I'm going to say if var is ... and then I don't care about what comes after that. So let's just run this real quick, see what it triggers on. Yep, that successfully triggers on line 20 It does trigger on line 28, which we kind of wouldn't actually want. So what we can do is we can filter that out by basically saying and is not if var is empty string. And now we've removed that. So this is essentially a Boolean composition. Like to get the last case, we would flip this around. You can probably guess we would say if quote dot 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 quote is var. There's actually a way to teach Semgrep that x is y and y is x are equivalent, so that you would not have to specify multiple variations on the same rule. But we'll come to that a little bit later. So skipping along to performance in the interest of time, where do we get ideas for performance checks? So at the generic level, actually the issue trackers for languages often, or frameworks, will have people complaining about like, hey, like why is this snippet unperformant? They can be a really good place to mine. My personal favorite is guides written by engineers who are obsessed with performance. They tend to write like very detailed blog posts or other material talking about performance anti-patterns. But the example that I'm going to show you is actually highly specific to Semgrep. It's our own known and embarrassing performance bugs. And so this is a bug that got filed earlier in the year from a user at Zulip. And they were basically like, hey, how come checking the version of Semgrep takes 0.2 seconds with a plus or minus 0.5 seconds? That's crazy. So if you didn't know this, the command line wrapper shell for Semgrep is written in Python. And then the core is a very fast statically compiled OCaml binary. And so what we have here, like I'm just giving you a sort of simplified view of the code. We were importing a top-level module, YAML, and requests in our case, which are actually quite slow to import. And so what we wanted to do is basically defer that import till later on inside the program execution. So line 4 here and all the code inside the function defined at line 9 are fine. It's this root level import that we really don't want. So, obviously the most basic example, you're like, all right, yep. So we type import YAML. That successfully finds line 1, but it also finds line 5 and 11, which is not so great. So now this comes back to the question that was asked in the chat about basically like, okay, like what is the pattern not inside for? So I will show you real quick. Basically, if I say and is not inside, and then I say def some function dot dot dot, don't care about the arguments to that function, this should stop triggering on our test cases. And indeed, this is exactly correct. Now that we're basically saying, hey, like I want to find code like this, which is not inside a function, we're only triggering on line 1, which is pretty nice. And so actually, if I switch over to the advanced view, you can see that we are using this pattern field inside here. It's nested under a pattern either, even though we don't need that. And we've got the pattern not inside with this def func. So there's nothing super magic. The visual editor is just writing the YAML for us. We've also specified a nice message, which if you try to make a pull request to Semgrep that avoids this behavior, you will get this message in CI now, which is pretty cool. So that's a very trivial example, I would say, of performance stuff. There's a lot of people who are doing things that are more sophisticated, but I don't have time to cover it for the purposes of this talk. So to close off with, I'm just going to give you a taste for some of the power user features, which are defined either in the experimental documentation, so don't rely on them too heavily, or are things that we're using internally, but they'll give you a little sense for the roadmap, which is the last thing that I'm going to end with. So the first thing is being able to do deep expression matching. So for instance, like here we have basically like, this doesn't require any kind of inter-procedural analysis to assess, but we are redirecting to an argument which is directly controlled by the user. But we're passing it through some function first. And what we'd like to do is basically say, hey, like, actually, I don't really care what the name of that function is, or like, really, even if there's an arbitrarily deep level of nesting inside this snippet, I would still like to be able to match when we've got request.args.get.foo. So let me just show you an example of what I mean, because I can copy this right here, and I'm going to want to qualify this by saying like flask.redirect and request.args is actually going to be flask.request.args, and then I don't really care what the parameter that's specified inside here is. This is just an anti-pattern where I'd like to say, hey, like anytime the arguments that are being grabbed are flowing to the redirect, this is a security vulnerability called an open redirect. So if I do this here, yep, that's great. What if I have something really nasty like F1, F2? So you can kind of imagine I can replace this with a meta variable called foo, but now I have to potentially do that arbitrarily deep, right? I have to do like foo1, foo2. This is not going to scale. And so the solution, if you ever find yourself in this kind of position, is to use a special operator called the deep expression operator, which basically looks like this. So it's a variation on the ellipsis operator that has a right bracket or a less than sign and a greater than sign. This syntax actually comes from an earlier tool called coccinelle. And what this allows us to do is basically say, hey, like anywhere inside this expression that this occurs, I would like a match. And so assuming I've done this correctly, we're now going to match it regardless of the level of nesting that happens inside this expression. So that's pretty cool. That's the first feature. The second feature, I'm just going to skip over it for sake of time. But earlier I was talking about how we had this pattern where we were saying, hey, if x is y, and really we wanted that to be commutative. We wanted it to be if x is y, even if we had if y is x, it should still match. And what you can actually do, Semgrep internally has these equivalences, which are basically rewriting and normalizing the code to a consistent form. So in this example, if we're getting a request argument, that example that we just had, there's two ways to get a request argument. I can say request.somevar.get, or I can say request. And then call it directly. This user-defined equivalence results in those being the same thing. So now if we had a bunch of rules, we've cut the number of rules that we need to write by 50% by using the user-defined equivalence. Pretty nifty, more of an advanced feature. It's not going to unlock any new capability, but it may make the rules that you end up writing significantly shorter in effect. So the last thing I want to show you is mixing Semgrep and grep, which is kind of a terrifying bastardization. But here's a cool example. So we're looking at the YAML view. We've got two patterns. We're using that pattern inside operator again to basically say, hey, like anytime somebody's instantiated a client with the host as a keyword argument, that's some string. And then we're combining that with a regex argument. So this regex is basically saying, hey, like anywhere within what you matched before, I would like to match this regular expression. And so in this case, we're successfully matching the first line, but not, or line 2, but not line 5. So that's pretty basic, but can be really powerful when you kind of need to break out of the AST structure and just do something simple with grep. The last example, which I think is really interesting, is what if we had like a module that was like, oh yeah, like it just has insecure 1, insecure 2, insecure 3, insecure 4. How could I match with a single Semgrep pattern all of the variations of, really I just want to say any module with a call that has a function name which starts with insecure. So this is something that is new in Semgrep as of a couple of weeks ago. I actually don't remember the specific version that shipped this. And I'm just going to paste in the example to the advanced view because we're about to run up on time. But basically I can say, okay, patterns, where I have a pattern that's just my module here, calling some method on it. I'm capturing method into a meta variable. And then I can specify a subkey, which is like, all right, I would like to specifically match a regular expression on that meta variable. So I specify the meta variable that I want, which is just my method. And then I've got my regex here, insecure 1, insecure 2, insecure 3. Obviously, I could collapse that down a little bit. And just to show you that I'm not cheating, I'll put in a fourth one here, and we should successfully match that case. So this is really powerful. You may recall, if you've been tracking Semgrep development, that you can actually also embed arbitrary Python code inside here. So you can have like a full Turing complete system for like doing advanced logic on the meta variable matches. Unfortunately, that's a little bit of a security loophole because it means that you must trust the source of your rules if you're allowing them to run arbitrary code. And so it requires this very scary allow arbitrary code execution flag. But if you use the regex on the meta variable, there's no arbitrary code required. It can be quite clean and quite concise. It's a nice way to combine if you already know regular expressions. Essentially, you just kind of use Semgrep to navigate to the right spot inside the AST, and then use regex to do the rest of the work. So people have gotten a lot of mileage out of it. I hope it's useful to you. Things that are coming up, better type inference. So we didn't even have time to talk about that, but we're investigating a couple different options to actually get much more precise type information. One of the sad things about Semgrep, which is both a pro and a con, is that it doesn't require compilable source. But there are systems like Language Server Protocol, which do decently well in the context of a degraded, semi-compilable project at getting you type information. So we would like to be able to integrate those even degraded sources into the Semgrep runtime so that you can match on types. Building up the constant propagation, so making it work better within files. Interfile is not necessarily on the roadmap yet, but it might be coming. There's also, as I mentioned, alpha support for taint tracking. If you look at some of the experimental documentation in Dig, you'll find that. And there's a lot more work coming on the polyglot language support. So TypeScript and PHP are the next two languages that we have planned. So yeah, this has been Semgrep. It's an open source code analysis tool that feels like grep. I hope you enjoyed the update and getting able to, watching me nervously write some rules live in front of you. I'm glad nothing exploded. So yeah, feel free to hang out. I'll be available in the chat. I think there are some other R2Cers here to just answer questions about roadmap, or if you have patterns that you'd like us to debug, happy to help.
Thanks,
Back to you,
Isaac.
Pablo.
Thank you very much. And we do have a question about the languages. Speaking of languages, when you parse all the languages, are you translating them all to the same IR for analysis? And is the IR based on the format you've been writing rules in, like having if-else statements and so on?
Yes, good question. So the sort of interesting factoid about Semgrep is that the same parser is being used to parse the pattern as the source code. So this is why it's not language independent. If you are writing a Python program, you need to write a Python pattern in order to search it. Behind the scenes, however, they are both being converted into a generic AST. So in theory, it is actually possible to use like a Python pattern to search a JavaScript program. In practice, we've seen only a few applications of this. And behind the scenes, I guess like to be really specific, what's going on since we've converted to treesitter, we use treesitter to turn text into a parse tree. It's a little more complex than that. We are automatically generating an OCaml parser from the bindings to the treesitter we're generating the OCaml data structure from the treesitter library. And then there's a conversion step from that treesitter specific grammar into the generic grammar. So Sigint, I don't know if that exactly answered your question, but there is a generic representation. However, the purpose of the tool is not really to provide a generic sort of like write in one language and apply to multiple languages. In fact, the fact that it's so cheap to write a Semgrep pattern in the first place means that it's just like less work to rewrite it in your target language.
No, that definitely answered my question. In fact, it was getting on to the point of this idea of a lot of tools like this end up getting stuck in C-like constructs, and I was curious how you were going to do non-that. But that's cool. Thanks.
Yeah. I mean, the weirdest thing to me is that eventually when we support something like Bash, you'll be able to write like an if-else expression in Bash, and in theory, apply that to C, which is terrifyingly bastardized, but there it is.
I have a question. Could you comment on the the maturity of the Visual Studio Code plugin? Because that's how I would be interested in using it.
Yeah, I don't have it. Well, actually, I do have it installed. It's in beta, so it's not like an official priority project. It's a 20% time project for somebody on the team. Mm-hmm. That being said, that person is a really good engineer. So it has been, at least for me, very stable at running. I've got a local Semgrep config, and I can use it. It does not support like some of the cooler features like the autofixes yet, but it'll definitely operate in a lint mode.
And so does it support all the kind of the features you were talking about of like, it's in this context, but not in that context, and pattern metavariables, all that sort of stuff?
Yes, it definitely does. So the engine is fully implemented inside the extension.
Okay, thanks.
Yeah, appreciate the question. And I see there's a question in the chat about, is there a non-web version of the rule writing UI? So no, unfortunately. For some of the customers that r2c has, we do provide a like on-prem instance if you don't want to be like putting company code into a remote live editor, that's pretty reasonable. But unfortunately, that's a paid feature. Of course, you can just like get your Emacs up with the rule YAML on one side and the output on the other side, but it's a little less convenient. Cool. Well, Pablo, there was a lot of novel live demoing in that for me.
Isaac, do you want to show
Hats
off?
off to you, yeah.
Isaac, do you want to show off the magic wand feature?
Oh yeah, we didn't get to that. So if people are still sticking around, I will show you something that's kind of fun. So we talked about the it's kind of painful to have to do this oh, you've got to fully qualify the module name that you're bringing in. So I'll switch back over to this. All right, is that coming through?
Yep.
Awesome. So one of the ideas here that we had, which was actually an intern project from Emma, our intern from CMU, was basically, okay, what if I could just highlight this snippet of code and see some suggestions for the Semgrep pattern that should go along with it. So if I highlight a valid expression and press suggest, it'll actually give me a couple different suggestions for variations of sort of varying specificity that would match this. So I can say, oh, yep, I want a string as the first argument, and then I don't care, or and string as the first and second argument, string as the first and second, and I don't care about what comes after that, or I just don't care about any of the arguments at all. And you can see that even though it was r.setCookie, we did from Flask import response as r, and the suggested pattern has successfully resolved that for us. So we can just press use, it updates it here. If we run it, it should automatically instantiate on all of these. And this is decently powerful, so it can also, if we highlight a larger expression, it should be able to suggest this. In this case, it's looks like it's failed a little bit. I'm not sure. I think I have seen it do function definitions correctly, as well as conditionals, which is pretty nifty. So your mileage may vary. Let's try it out. But we plan to invest more into this, and because Semgrep now has support for types, this can be very helpful for essentially understanding, hey, what does the generic AST think that the type of this object is inside this context?
So just looking at that example there, I see those functions have annotations for the app root thing. Is that something Semgrep can be sensitive to as well?
Yeah, it can. So I'll just copy and paste this, say func, and we can actually use this to say the path we can extract from the annotation. And this works not just in Python, but in Java and other languages as well. And the cool thing here is that because the metavariables are bound into the output message, if I switch over to the advanced view, I'll change the message and I'll basically just put path func, so a comma separated extraction of the metavariables. And then the Semgrep output is basically just going to have this is also available if you're running this locally, use --JSON, and then you can put this in a pipeline where imagine you have it set up in CI and you want to tag somebody on a PR, but only if that PR is adding or removing a route to the application, for instance. So this is actually we've used this a ton with some of our customers to rapidly prototype things like a sort of asset inventory for code using Semgrep, or be much more precise in terms of, oh, let's give you some semantic information about the PR before you just start tagging people from the security or some other team. So yeah, thanks for the question. And that's, I guess, maybe a little more specific, but an application that we found for it.
Nice.
Yeah, thanks for the question. By the way, Scott, I noticed that you had a semgrep.c file on I think GitHub or some other version tracker that predated our thing.
Oh yeah, it's one of the top search results for Semgrep.
Right. So I hope you don't mind that we renamed it from sgrep to Semgrep. But the domain names and package names were available for the latter.
Yeah, I think that must have been from my C++ parser from when I was a graduate student. That was an example application. It was grepping for casts, right? Implicit casts.
Yeah.
Yeah. Okay. So, but you're certainly welcome to take over the purchase of that. I'm not doing anything with it.
Yeah, I appreciate it. Cool. Well, that's all I got, folks, unless there are more questions. Thanks so much for joining for the meetup. Obviously, it's a little bit more fun when we're all in person, but hope this was a helpful introduction. And we do all hang out on Slack. We're quite responsive there, as some of you know. So feel free to join and bug us with questions or bug reports.
Great. Thank you so much, Isaac. And thanks everyone for joining. I know for some of you it's late. For some of you, it's very early. We have the whole world pretty much represented here. So thanks, and hope to see you soon.
All right. Have a good one.